Hi, welcome to Physics Teacher. In this grade 11 chemistry tutorial, I'm going to show you how to determine which compound is your limiting reagent before we do our stoichiometry calculations. Now, if you haven't already, please go see the tutorial on nomenclature, chemical reactions, and stoichiometry before you attempt solving for a limiting reagent. Alright, so in this question we have copper metal obtained industrial from a single displacement reaction of copper 1 nitrate. So copper 1 nitrate would be CuNO3. And iron metal, so plus Fe. And in a single displacement reaction, because iron is more reactive than copper, it's going to replace copper. So we're going to get Fe, NO3, 2, because iron will have a charge of plus 2, and copper, which is what we're looking for. Alright, so before we move ahead, we need to balance this reaction. So here we have 2 nitrate ions, and here we only have 1. So I'm going to put a 2 here. And now we have 2 coppers, so I'm going to put a 2 here. Iron, here we have 1 and 1, so we're fine. It's balanced now. So what we have is 2.3 kilograms of copper nitrate and 1.5 kilograms of iron. Now in a typical stoichiometry questions, you might get the amount of one reactant or the other, and then you'll use stoichiometry to determine the amount of either one of the products. But in this case, we're given both. So what we have to do is determine the limiting reagent. So what is a limiting reagent? Well, let's say we wanted to make a cake. And to make this specific cake, we need 2 cups of flour and 3 eggs in this example. Now, if I have 5 cups of flours and 9 eggs, how many cakes can I make? Well, I have enough eggs to make 3 cakes. But I only have enough flour to make 2 cakes. So what this means is we could only actually make 2 cakes. Flour is our limiting reagent. It is the one that is going to determine how many cakes we can make. And our 3 eggs, we say, is in excess. So we have more than enough eggs than what we would need to make 2 cakes. Alright. So how do we determine if it's the copper nitrate or the iron that is our limiting reagent? The first step is to find out how many moles of each we have. So let's start with copper nitrate. Now the number of moles equals the mass over the molar mass. Now the mass here is stated in kilograms, but for every kilogram we have 1,000 grams. So this is going to be a mass of 2,300 grams. Now the molar mass we get from our periodic table. So let's start with copper. On our periodic table, copper has a molar mass of 63.6 grams per mole, plus nitrogen, which is 14.01, plus we're going to have 3 oxygens, each being 16 grams per mole. And so that'll give us 18.3 moles of copper nitrate. So now let's look at how many moles of iron we have. So again, number of moles is mass over molar mass, where the mass of iron is 1,500 grams, divided by its molar mass of 55.9 grams per mole, which gives us 26.8 moles. Okay, now here's how we're going to determine the limiting reactant. We're going to take one of our reactants, doesn't matter which one, and using the amount of moles we have for it, determine how much of the other will be required to completely use up all of those moles. So let's start with copper nitrate. Again, it doesn't matter which one we choose. So copper nitrate has 18.3 moles. So my question is, how much moles of iron will be required to completely react with 18.3 moles of copper nitrate. So let's figure that out. So our ratio is 2 to 1. So we have a 2 to 1 ratio of moles of copper nitrate, which we have as 18.3 moles of CuNO3, divided by the number of moles of iron required to completely react with all that copper nitrate. So if we rearrange for the moles of iron, we get 18.3 moles divided by 2. And I'm just cross multiplying there, which gives us 9.2 moles of iron. Alright, so what does this tell you? It tells me that to completely react with all of the copper nitrate that we have, we only need 9.2 moles of iron. But we have 26.8 moles of iron. We have way more iron than is required. So iron is in excess, and therefore copper nitrate is our limiting reagent. Now we can move on and figure out how much copper we actually get. So to figure out how much copper we're going to get, in the reactants we're going to use our limiting reagent. Now in this case the ratio is 2 to 2, which is the same as 1 to 1. So that means we also have 18.3 moles of copper in our products. So I can then determine the mass of copper by taking the number of moles multiplied by its molar mass. So we have 18.3 moles multiplied by the molar mass of copper, which is 63.6 grams per mole from our periodic table, and that gives us a mass of 1164 grams, or keeping to our two significant digits, I'll round that out to 1.2 kilograms of copper.